Hi class. Today we're working on section 2.1, which is right triangle trigonometry. So for the first example, we're given a right triangle with the side that is missing. So to find that missing side, we're going to do the Pythagorean theorem. So we can say a squared, which is 6, a squared plus b squared, which is unknown, is equal to 10 squared, which is the hypotenuse. That's 36 plus b squared equals 100. B squared equals 64. Once you subtract 36 to both sides, take the square root of both sides of the equation, you get b equals 8. So now we know that this is 8, so we have a 6, 8, 10 right triangle. Now we can find the 6 trigonometric functions of a. Let's start with sine of a. Sine, if it helps you to use this acronym, SOHCAHTOA. I think this is very helpful if you're just learning this for the first time. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So the sine of angle A is going to be the opposite over the hypotenuse. So that's going to be 6 over 10, which would be 3/5 if you simplified that. Cosine of A is going to be adjacent over hypotenuse. So that's 8 over 10, which turns out to be 4/5. And then we have tangent, which is opposite over adjacent. So that's going to be 6 over 8, which would be 3/4. Once you have those three main trig functions, you can find the reciprocal functions by just taking the reciprocal of the ratios. So cosecant is the reciprocal of sine, so that would be 5 over 3. Secant is the reciprocal of cosine, that would be 5/4. And cotangent is the reciprocal of tangent, which would be 4/3. Okay, here they just kind of label this. Side A is always going to be opposite side angle A. Side B will be opposite angle B, and angle C will be opposite side C. Here they're telling us what a cofunction is. So it turns out that sine and cosine are cofunctions of one another, which means that when you take the sine of A, that's going to be equal to taking the cosine of B, where you have this condition that A and B are complements of one another. So A plus B has to equal 90, then this will be true. So the other cofunctions are secant and cosecant, tangent and cotangent. All right, so let's see how this can be applied. So they say they want us to fill in the blank here. Well, the cofunction of cosine is sine, therefore we need to find the complement of 30. And the way we do that is we subtract 30 from 90, which is 60. So there you go, 60 plus 30 is equal to 90. That's why that would work. Over here, tangent and cotangent are cofunctions of one another. So we do the same thing. We subtract 30 from 90 to get 60. So in this case, we're going to subtract y from 90 to get the complement. So subtract y from 90, and that's how you get the complement. All right, and you can also do the same thing where you're adding this angle plus this angle, and you should get 90, which you will, because these angles are going to cancel each other out. All right, and now secant and cosecant are also cofunctions, and the complement of 75 would be 15. 75 plus 15 is 90. So that's how those work. Here they're showing us two special triangles, which we have kind of discussed before. You have a 30, 60, 90 triangle, and you have a 45, 45, 90 degree triangle. And when you have these two special triangles, it turns out that if the short leg is 1, then you can get from the short leg to the hypotenuse by multiplying that by 2. So that gives us 2 for the hypotenuse. And the way you get from short leg to long leg is you multiply by radical 3. And that's how you get the long leg. When dealing with 45-45 triangles, if the two legs are equal to 1 in length, to get from the leg to the hypotenuse, you would multiply by radical 2. So it comes in handy because there are these special angles on the unit circle, which we will talk about soon, maybe in the next couple sections. And using right triangle trigonometry will allow us to find the ratios, because we know that sine, for example, is opposite over hypotenuse, or cosine is adjacent over hypotenuse, and so on. And so we can find all these values here. For example, the sine of 30 degrees. We would go to the triangle that has a 30-degree angle, which is here, and we would find sine of that, which is opposite over hypotenuse, so that would be 1 over 2. And so that's how they come up with that. Let's try a tangent problem. How about we try tangent of 45? So you would go to the 45, 45, 90-degree triangle, and tangent is opposite over adjacent. So that'd be 1 over 1, which is 1. And that's how they get 1. So you can do that for any of these values. For any of these angles, you can find their trig ratios by using SOHCAHTOA. All right, here they want us to substitute 30 in for x, so let's do that. So you have 2 sine of 30 degrees. Well, we know that sine of 30 is 1/2, so now we have 2 times 1/2, which is 1. Let's try the next one. So now we're going to plug in 45 into y. So you have 2 times 45, which is 90 degrees. This is a special case where it's in between quadrants. The 90-degree angle is here. And so if you're looking at a point, any point here, let's take 0, 1. Sine is always going to be your your y coordinate, and cosine will be the x coordinate. So in the cases of these special quadrantal angles, as they call them, you can just base it off of you can base the answer off of the fact that sine is a y coordinate and cosine is the x coordinate. So for the sine of 90, this is 90 degrees. We're looking at the y coordinate, which is 1. So this is going to be 1. All right, over here we have 30 times 3, which is 90. 90 minus 90 is 0. So there's another quadrantal angle. So we have 4 times the sine of 0 degrees. Well, 0 degrees is here, and that point would be 1, 0. And since we're looking for sine, that's the y coordinate, that would be 0. So we have 4 times 0, which is 0. That's how you can find what those trig functions are. All right, let's look at the homework. So here's the homework. I'm going to go ahead and skip these fill in the blanks because these are just definitions that I'm sure you'll be able to find in the PowerPoints. All right. These are also just definition problems where you're trying to match the cofunctions. We know that this cofunction of sine is cosine, right? The cofunction of secant is cosecant, and the cofunction of tangent is cotangent. You can look at the PowerPoint to see that. For this next homework problem, they want us to find the 6 trig functions given this triangle here. We need to find the missing side, which we can easily do by applying the Pythagorean theorem. A squared plus b squared equals c squared. That would be 64 equals 100. Subtract 64, you get 36. Take the square root of both sides, you get 6. So here we have 6 for this side. And now we're looking for the sine of angle A. So you go to angle A, which is here. And since sine is opposite over hypotenuse, that would be 8 over 10, which simplifies to 4/5. All right, cosine, same thing. Cosine of A would be adjacent over hypotenuse this time, so 6 over 10, which simplifies to 3/5. All right, and then the tangent of angle A would be opposite over adjacent, 8 over 6, which becomes 4/3. All right, and then you can either just, now for this next one is sine of B, you would go down here to angle B and you would do the same thing. Sine is opposite over hypotenuse, which is 6/10, which is 3/5. Or you could have used cofunctions. Remember, cosine and sine are cofunctions of one another, and A and B are complements because they're on the right triangle here. So we know that those are complements, therefore this should equal this, which indeed it does, 3/5. All right, and the sine of A should equal the cosine of B, so we should get 4/5 for this value as well, which we will because the cosine of B will be adjacent over hypotenuse. 8/10, which becomes 4/5. And lastly, tangent of B would be opposite over adjacent. So 6/8, which is 3/4. All right, that does it for that problem. For this one, they want us to use a cofunction theorem, which means since we know sine and cosine are cofunctions of one another, we just need to find a complement to 75 degrees, which is 15 degrees. All right, they want us to fill in these blanks. They give you the angle x, and then they give you the sine values of those angles. And now they want you to find the cosecant values, which is just the reciprocal of sine. So all you really have to do is take the reciprocal of the ratios, and that does it. So the reciprocal of 0 is 1/0, which is undefined. So there we would enter undefined. The reciprocal of 1/2 is 2. The reciprocal of rad 2 over 2 would be 2 over rad 2. If Webesign does not accept that, then you would rationalize that. You would get 2 rad 2 over 2, and then you can actually simplify more. Final answer would be radical 2 for that problem. Same thing over here. You would do 2 over radical 3 for the reciprocal, rationalize, and that would be 2 rad 3 over 3. All right, and then the last one, the reciprocal of 1 is 1. All right, here they want us to simplify this expression. So we know that the sine of 45, we can always refer to the right triangle that we have over here, or you can use this table if you'd like. But you can also use that right triangle. So the sine of 45 would be, sine is opposite hypotenuse, so 1 over radical 2. So now we have 10 times 1 over radical 2, which is 10 over radical 2. And if we rationalize the denominator, we will get 10 rad 2 over 2, which becomes 5 radical 2. All right, over here, replace x with 30 degrees. So if you do that, that becomes 60 degrees. So now we have negative 3 times sine of 60 degrees. Once again, we go to 60 here. Sine is opposite over hypotenuse, radical 3 over 2. So now we have negative 3 times radical 3 over 2, which is negative 3 rad 3 over 2. All right, here we're going to substitute x was 45. So 2 times 45 is 90. 90 minus 45 is 45. So we have cosine of 45 degrees. And once again, we can go to our right triangle. Cosine of 45 would be adjacent over hypotenuse, 1 over radical 2. Whoops, sorry about that. What did I do? That was a mistake. And so we said it was 1 over radical 2, so that would be 4 over times 1 over radical 2, which is 4 over rad 2. Rationalize, and we get 4 rad 2 over 2, which can simplify to 2 rad 2. All right, moving on. So for all these problems, you can pretty much follow the same thing that we've been doing. We've been looking at the right triangle. So I'm just going to go jump down to this problem number 11. Let's look at the cotangent of 60 degrees. So here's 60 degrees. Cotangent, by definition, remember, would be adjacent over opposite. It's a reciprocal of tangent. So it's going to be 1 over radical 3. So it's going to be 1 over radical 3. That's because cotangent, by definition, is adjacent over opposite, which we said is 1 over radical 3. Let me double check that. Adjacent over opposite. Yeah, 1 over radical 3. And we can rationalize and get radical 3 over 3. For the last problem, we are going to, they want us to find, suppose each edge of the cube is in the figure is x, so that means that this is x, x, x. Everything is x because this is a cube. Find the sine and the cosine of the angle formed by the diagonals CF, which is here. So one that goes from one corner to the other, to the opposite corner. And then CH, which is the diagonal on the bottom of the box or the cube. So we have this right triangle here, and you also have this right triangle here. So let's focus on the one that's on the floor, the one that's flat on the ground, that right triangle. So if I draw that out, it's going to look something like this. Well, this is C, D, and this is H. Well, we know that this is X and X because all the edges are X. Therefore, this is an isosceles triangle, which means this has to be 45, 45. And remember, the way you get from a leg to the hypotenuse on a 45, 45, 90-degree triangle is you multiply this by radical 2, and that gives you the hypotenuse. So this is going to be x radical 2. All right, and now we have enough information. We know that this is x radical 2. We just found it. We know this is x, and now we can use the Pythagorean theorem to find the hypotenuse. So let's draw that in red. So this is the bottom, which we found out is x radical 2. This is your CHF. This is x. And we're looking for the hypotenuse now. So if we do the Pythagorean theorem, we're going to get a squared plus b squared equals c squared. I'll call that c for now. C squared. So when you square this, you're going to get x squared, and this becomes 2 because the square and the square root cancel. So you get 2x squared plus x squared, which is equal to c squared. C squared is going to equal 3x squared. So if you take the square root, you're going to get c is equal to, the x squared comes out as an x, and then the radical 3 stays there. So this is going to be x radical 3. And they want us to find the sine and cosine of the angle formed by the diagonals of CF and CH, so this and this diagonal. So therefore, they're referring to this angle here. I'll call it theta. So the sine would be opposite over hypotenuse. So that's going to be opposite over hypotenuse, which is just 1 over radical 3. You can rationalize that if you would like. You may have to. I'm not 100% sure. And then the cosine would be adjacent over hypotenuse. So that would be x radical 2 over x radical 3, which is radical 2 over radical 3. And same thing, you can rationalize that as well. So that completes or concludes this section.